Hello to all. First, let us thank you for the interest and trust you have shown in us. Also, following your requests, we have therefore created this little tutorial to reveal some of the secrets of creation and of 3D object animations with the PTE AV Studio 10 Pro program. Indeed, this program allows the realization, more or less easy, of any animable object, and texturable, that is to say to apply a photo, or several, to it. We must first clarify certain things. Yes, the objects you will create will be virtually pure 3D, that is to say, they will have a width, a height and a depth. Yes, also, you will create a virtual space in 3 dimensions, in which you can place and animate your objects. No, the program will not calculate the parts that may be visible or hidden by another object. Also, the program cannot calculate the collision or the overlap of the different objects between them. Thanks to all this, we enter a virtual world where many things are possible, even if they could not be in reality. On the other hand, we will have to determine the order of visibility of the different objects, with respect to each other, and also, which is the most difficult, to do the same for the elements of each object, relative to other elements of it. Let's see some small concrete examples. First, a simple cube. Here, I'm not going to texture it, only color it, and make it semi-transparent, which allows us to see that all the faces are well created, and that if we rotate it on itself, the proportions 3D are present and respected. In these examples, the aim is just to demonstrate what I have just stated above. We will see the object realization later in this tutorial. Second, we keep our cube. I'm just going to add a horizontal squared plane. There you go. And now, I move our cube in the virtual space of the program in its 3 axes. Horizontal in width, the base axis X. The vertical in height, the base axis Y Greek. And the horizontal in depth, the base axis Z. We see that the parts and the size of the cube are modified following their displacement in real perspective with respect to the camera which generates the view. For information, it is not the camera that moves, but the virtual space and all the objects that are linked to it. Hey wait. You are going to tell me, how come the camera does not move? Well yes, in this virtual world, the camera is fixed. The movements are given to the objects, which creates the illusion that we are moving in this world. Third, if now I place a different texture on each side of the cube, and that I rotate it on itself. Oh surprise! What is that? Some faces, at some times are visible, whereas they are theoretically behind another, and therefore, they should not normally be seen. Yes, but, remember, the program does not calculate the real position of the elements to display them or not. It will be up to us to overcome this inconvenience by other means. Fourth, since also that program does not calculate collisions and overlaps between elements or objects, this will allow us to create effects that would be impossible in reality. An example? Let's put 2 cubes side by side, then rotate them. It works. Although physically impossible, but we are in a virtual world. So many things are now possible. Here in a nutshell, the basic rules of the virtual world created by the PTE AV Studio. Now, a little practice. Let's get started with virtual creation. As we have just said, the camera is fixed, and these are the elements that move. A word of advice. Let's always create our virtual space first. How? Simply by creating an empty, square frame and placing it horizontally. To do this, click on Add Frame. In the Properties tab, give it a square dimension, for example, 1024 by 1024. Why transform it into a square? Simply, the lengths and widths of the elements determine their positions in space as a percentage virtual. If we use another format, as the base 16/9, the displacement and size ratio will also be of this ratio, and therefore, if we move the object in one axis, the equal displacement in the other axis will have to be calculated based on this ratio. Using square frames, the ratio is 1:1, and therefore, does not require any calculations. Now let's rotate our frame to place it horizontally. Why? This is also for convenience, for the human being. In displacement mode, the axes X and Y are the terrestrial displacements, therefore, the displacements represented in virtual by the horizontal axis X and horizontal axis Z, and the vertical displacement, or altitude, in real by the Z axis, but in virtual, by the Y axis. So, simply by laying down our main plane, the Z-axis at 90 degrees, we virtually swap the Y and Z-axis, so that they correspond to our reality of displacement. Let us name it Master. It is it to which we will link all our objects, and which, by moving it, and/or rotating it, will give the movement of the camera, and will create the illusion of our displacement, and the movement of objects, in our virtual world. Now let's see the creation of different 3D objects. For more ease, and to better navigate if there are many objects, we will create a frame for each object, to which we will give the name of the object, and it is this one that we will handle for animate the object which is attached to it. Let's start with the simplest, the cube. So let's create a frame for it, a frame that must be linked to the main frame. To do this, select the main frame by clicking on its name in the list of elements, then either click on Add Frame in the top bar, or right-click on the master frame element, and, in the drop-down menu, click on Add Frame. It's done, but our frame does not appear. It's normal, it is lying down and at the same level as the main frame and in the center of it. Let's rotate it less than 90 degrees on its Y axis to straighten it. And, as for the main frame, let's give it a square shape in the Properties tab, or 1080 by 1080. And let's name it Cube. It will be the virtual center of our object. You can see that the frame covers the height of the visible space. In the tab Animation, let's modify its size so that it corresponds to the desired size of our cube, for example, 50%. If the X and Y zoom values were not related, give the same value to both coordinates. If they are related, then this happens automatically, whether you change X or Y. Let's add our first face. Select the frame, cube, then either Add Image in the top bar, or right-click on the cube element in the list, and in the drop-down menu, click Add Image or Video. In the future, I will no longer specify these possibilities, they should normally be acquired, and you will use the one you prefer. Our first face is created, but, with the exception that the chosen image is square, it is rectangular, and a cube has square faces. We will fix it, the program can do this automatically. Let's go to the Property tab, then, let's use the command Aspect Cropping, check its validation box, and in the new menu that has just appeared, Ratio of Aspect, let's select the value 1:1. We see that automatically, our photo is now squared in its center, and resized to perfectly match the frame, cube. Now, to lock this image, check the command Main Object, and we see that automatically this one takes the value 1. That's fine, because if now we want to change image, this new one will be automatically cropped and will replace perfectly the original. You can try it out by selecting another image using the command image. You can also rename to recognize it more easily in the object menu, for example, front panel. Now we need to put it in place. Given that each face is half its size in relation to the center of the cube, and that half the size of the frame equals 100% displacement, we are therefore going to put our face at -100 on the z-axis, the depth axis of the cube. Here it is now in its correct place. We can verify this by rotating our cube. Let's move on to the second side, the back side. For more ease and speed, we are just going to duplicate the front face. Click on it in the list to select it, right-click on its name again, and, in the drop-down menu, click on Copy. Now select your frame, cube, right-click on it, and in the drop-down menu, click on Paste. You don't see it, because the two images are exactly superimposed, but the second face has been created, and you can see it in the list of objects. If this was not the case, select one of the two faces in this menu. As long as we are in the tab Animation, we will put it in its place. This must be on the opposite side of the front face, therefore, we are going to modify its Z position, from the value -100, to the value 100. If you have selected the first face in the list, you now see that there are 2 times the image, one larger, and the other smaller. If you had selected the second side, you will only see one image, the larger one. This is normal in both cases, because, do not forget that the program displays the images one after the other in the order of the list of elements. We will solve all these small problems in a single operation at the end of the complete creation of our cube. Now, if by rotating the cube, we place the back face forward, we notice that the image is inverted, and that we see the back. Let's select this one in the list, then, let us rotate it on itself and its vertical axis, the x-axis and rotation, by 180 degrees. Here we are now seeing the front of the image in the right direction. Before modifying the image, if you want different images on each face of the cube, let's reposition our cube in its initial rotation, so that the front face is in front, then, reselect the back side. To check that it is the one that is selected, it is the small yellow frame around which will indicate it to you. If you want to keep the same image on all the face, go directly to the creation of the next face, otherwise, go to the tab, Properties, and uncheck the function, Main Object. With the command, Image, select the one you want to apply to the back face. Once done, rename it in the Name field, to Backside. Now recheck the option, Main Object. You will notice that this time, it is the value 2, which is assigned to this face. Indeed, the program automatically increments this value each time you add an object main. On the same principle, we are now going to add the 4 remaining faces more quickly. The way is the same for all 4, as we did for the rear face, only the values of rotation and position are different. Let's go back to the tab, Animation. First, the right face. Let's duplicate our front face. Rotate it 90 degrees to the right so that its front face either to the right, or 90 degrees on the y-axis. The right and left faces are centered on the x-axis, and moved on it. Therefore, we center our image by resetting its displacement on the z-axis to 0. Then, we move it to the right on the x-axis by +100. Here it is now in its place, and all you have to do is modify it in the Properties tab. Once done, if you have chosen another image, its main object index is on 3. Let's proceed identically for the left face. Only the rotation and position values must be reversed so that its front face is to the left, either a rotation of -90 degrees on the y-axis, and a displacement of -100 on the x-axis. After changing the image in the Property menu, you should have something that looks like this. Only the 2 upper and lower faces remain. For these, they will center on the y-axis, and rotate on the x-axis. So, for the upper face, we have a rotation of 90 degrees upwards, 90 on the x-axis, and a displacement upwards, or -100 on the y-axis. And for the lower face, a downward rotation of 90 degrees, that is to say, -90 on the x-axis, and a displacement down, that is to say +100 on the y-axis. Our cube is completely created, but, as I told you at the beginning, if we rotate it on itself, it is not at all the expected result. Indeed, the faces are displayed in the order of the list of elements, and we see front faces and back faces in their order of appearance, and not as they should appear. The simplest trick is, for our cube, that we must not see the back faces, or, in other words, the rear of the images, which, at the same time, will erase the faces which will be directed, same a little bit, towards the back, and thus, will solve our problem. The program allows you to do this in a single operation. Let's go to the tab, Property, then, select all art faces. To do this, either click on the first one, then click on the other 5 while holding the key Control pressed, either, and it's the simplest, click on the first, then on the last while holding the key Shift pressed. Now that all the faces are selected, uncheck the option Show Backside. This will be done for all the selected images. That's it. If now we go back to the tab, Animation, and rotate our cube again, the result is correct and as we wanted. Well, let's take a little more complexity. Don't be afraid, we'll take it step by step. Now imagine that our cube has semi-transparent faces, like in this example. When we rotate it, we should also see the interior faces of the cube. Or, also like in this other example, an exploded cube, where we also need to see the interior faces when rotating the cube. We will see how to create this second example. It's very simple. Indeed, each face is moved by +100 or -100 on their base axis, respectively. The z-axis for the front and rear faces, the x-axis for the left and right faces, and the y-axis for the top and bottom faces. All you have to do is modify this value by adding the desired opening distance of the cube. In this example, I move them 50 outwards. So let's change the position value of each face in turn from either +100 to +150, or from -100 to -150. In the current state, nothing has visibly changed, because only the front face is directed towards the front, and all the others, either partially or totally, towards the rear and are therefore invisible. If we rotate our cube, then, indeed, we can see the other faces when they are facing forward. So we also have to see the back faces of the images, but, if we activate their visibility, we will end up with the same problem. When a back face is in the logical list, in front, it will be displayed. The problem is therefore that the back faces, or the rear of the images, must always be behind. The statement of this problem gives us the solution. Let's duplicate our cube, and the first will display the external faces, the front of the images, and the second, the back faces, the rear of the images. To do so, go to the tab, Properties, select the 6 faces of the cube, use the command, Copy, select the frame, Cube, and use the command, Paste. Here we have 12 faces attached to the base cube. The first 6 will be the external faces, the front of the images, and the last 6 must be the internal faces, or the back of the images. For the moment, all the faces have only the function front, which is active. Select the last 6 faces, then uncheck the option Display the front, and check the option Display the back. And there you have it. Simple, but efficient. Let us rotate our cube to see that the result obtained is indeed the expected one. Indeed, it works perfectly. And, since each inner face has the same main object value as the corresponding outer face, maybe it's a copy of it, so we can change the image to one operation, either on the external face, or on the internal face, and this one will be automatically applied to the corresponding reverse face. Now let's see the reverse, or the inside of a box. To do this, we will use our base cube. And we're going to make it bigger so that it covers the entire visible screen. To do so, we just either have to move it towards us, therefore on its y-axis, or we modify the size using the associated function, and this, equal values for x and y. Whatever the method, but we should have something like this. Now we should only see the inside faces of our box. To do this, there are 2 possibilities. The first consists in simply removing the 6 exterior faces. Yes, but this method means that we will see the inverted images in our box, since we only see the back faces. If that's a problem, we will use the second method. It is a little longer, but has the advantage of displaying the front of the images in our box. Suppress first all the inner sides. Now for the front, back, right and left faces, we need to rotate them 180 degrees in addition to their initial rotation on the y-axis. Either 180 for the front face, 360 or 0 for the rear face, 270 for the right face, and 450 or 90 for the left face. For the top and bottom faces, we must rotate them on their z-axis. Also 180 degrees, so 180 for the top face, and also 180 for the bottom face. Here, if now we rotate our box, we see that we have the desired result. Well, let's continue our progression in our 3D universe. We are now going to modify the size of our box. Let's say that its height will be worth half of its length and width. It's very easy to do. In this case, I used all images in the format 16:9 horizontal. To continuing this example, I invite you to do the same, and if necessary, to replace your images by other, in this format. For the moment, do not modify the clipping ratio, which is 1:1, for all the images used. Well, this done, we can continue. As we said before, the size of the frame on which the images are fixed determines their dimensions. Here we have square images. Even if their basic format is different, it is always the cut ratio of the image that takes precedence, and therefore each image perfectly covers their fictitious location. We also know that in the size ratio, it is always the largest value that covers 100% of the fictitious frame. We want the box to have a height corresponding to 50% of the size of its base. Therefore, each side image must have a height of 50% in relation to its width. So either 100% in width and 50% in height, which gives us a ratio at 2:1. Let's try. Let's select our 4 sides, either the front side, the back side, the right side and the left side. Then, in the split command, enter the value 2:1. And it works. Now the top and bottom faces are still at 100% height. Since our box is now only 50%, let's try to modify their height so that it matches our box perfectly. To do this, go to the tab, Animation, then select our bottom face. We see that its displacement is +100 on the y-axis. Let's modify this value by 50% of it, that is, +50. And yes, it also works. Let's do the same for the top face. Its value is -100 on the y-axis. So let's change it to -50. And now, if we rotate our box only on its horizontal plane, we can see that we have the result we wanted. If we look at our box, we can move slowly towards something else. To guide you, let's change the texture of the different faces. Here, I use simplified textures. My goal is to help you design your own creations, not to make art. And yes, we now have a square room where we are inside. Good, but it's all a bit empty, and in itself, not very useful. Not so sure. Let's decorate our room a bit by hanging a painting on each of the walls. First, remember that items always appear in descending order of the item list. So let's place each of the pictures representing the paintings, each time, before those walls on which they are arranged. Let's start with the back wall, or the back side. This is the one we can see best for the moment. Select the rear face, then click on Copy. Then, select our cube frame, then use the command Paste. It has been created to first position in our list of elements composing our cube. Normally it is selected. In the Properties tab, uncheck the option Main Image, then, let's modify it by choosing the desired image using the command Image. Finally, here we can use the basic format of our image, and so, uncheck the image cropping command. So we now have to move it down in our list, until it is just in front of the back side. To do this, press the Ctrl key, keep it activated, and use the Page Down key, as many times as necessary to move our image to its place in the list. If you go too far, you can use the key combination Ctrl and Page Up to move it up. This done, our image is a bit large for our wall. Let's modify its size in the tab Animation. Let's say 33% in X and Y so that it covers 1/3 of our wall over its width, and 2/3 over its height. We can use as many images as desired, modify their sizes, as well as their positions on each of the walls. It can give this type of result. Here is another example a little more evolved, but using the same principle. I only use the front faces of the images, and, for the walls, they are placed in the order of their visibility wall by wall, and this by including the images, that is to say, for example, for the back wall, we have in the order the first 2 left and right separations directed towards the front, then, the second separations, the image, and finally, the back wall composed of 6 elements. Finally, the floor and the ceiling are placed last in the list. So our list is composed as follows: the base frame, to which I give the movement animation, the support frame of the cube which is linked to it, and in order and linked to this, the dividing walls, left and right, first, the first directed forward, then, the second, and their repetitions, for those directed backwards, but reversed, since they are seen from behind our stage. Follow all the image in the pictures. Then the wall frames, strictly speaking, containing all the elements forming this 1/6 per wall in this example. And finally, the floor and the ceiling. We saw in this first part how to create real 3D objects, on the principle of attaching the different component elements of the object on a basic frame. In the second part of this tutorial, we will see a different method. Even if basic, the created objects will always be linked to a basic frame. Here, we will attach the elements between them. This method will allow us to create undulating or curved images, or even our famous sphere. Let's see it step by step. We'll start with this little example. You will see that its creation is very simple. Here, it is the animation which is a little more delicate. Advice: activate your grid and adjust it so that you have a vertical and horizontal marker in the center of the animation. It will allow us to correctly place our elements, and also, to be able to position their control keys at very precise times. Okay, so we can start. As with all my animations, let's start with the basic lying square frame. We attach our square object control frame to it, straighten it out, and scale it down to 50% size. We will set up its animation just after positioning the first image. In this example, I have put all the images in square format, 1 to 1 inch the command aspect crop, but nothing prevents you from using another format, such as 16/9 or the 4/3. It will work as well, as long as you give the same format to all the images, and I only use the front side. So don't forget to uncheck the command display the back for all. Now let's add our first image, attached to the object's control frame. Let's now move our image forward, by its half width, that is, -100 on the z-axis. That's all for this image. It will not have any specific animation, it will only undergo the animation of the control frame. We are now going to give the complete animation to our control framework. Note that the total animation time is 30 seconds, so before going any further, check this using the command configure view, and, if necessary, modify it. The control frame is animated in 3 stages. First, its displacement from the outside left to the center. Second, its rotation on itself, a full turn. And finally, its movement to the right, until all the images have exited the screen. Here, we need 5 seconds for the first movement, 8 seconds for the rotation, and 15 seconds for the second movement, plus 1 second before and after the animation, which I put for the entry and exit transitions. That gives us a total of 30 seconds. Let's go, set the time to 0, then, let's move our frame until the image is totally outside the screen on the left. This gives us our value of -230 on the x-axis. Let's place the animation start key. Let's move the time slider up to 1 second. Be careful, the program does not allow you to give a precise time to a key, therefore, place your timeline as precisely as possible. Click on Add Key. Then, check the commands Peno and Rotation to activate them. We won't need the other commands, so there is no need to select them. let's place our end key of the first movement 5 seconds after the second, or at 6 seconds. At this moment, our cube must be exactly in the center of the screen, either at 0 on the x-axis. As for the previous key, activate the commands Peno and rotation for this key, and set Peno x to 0. We are now going to place our rotation key. As the rotation lasts 8 seconds, we set our new key to 14 seconds. Activate the controls Peno and rotation. Our object will make a complete turn on itself, in an anti-clockwise direction, in -360 degrees. Enter this value in the field C of rotation. Nothing has apparently happened, since our object is at exactly the same position, but if you move the time cursor between the 6th and the 14th seconds, you will see that the rotation movement has been given. Let's now set our last animation key to 29 seconds. Then, check the commands Peno and rotation to activate them, and, finally, let's move our frame out of the screen to the right, and far enough so that all the images are outside the screen, which gives us a displacement of +500 on the x-axis. The animation of the control frame is almost finished, because there will be a small problem to solve, which we will see at the end of this example. We can now add our second image. To do this, select the first, then, either add the second, not forgetting its properties, or click on Copy, then on Paste, and modify the choice of image in the Properties tab, and, in both cases, return to the Animation tab. You should have the second frame linked to the first one, but larger and placed in front of the latter, so that you no longer see it. If you have followed all the explanations given so far, a little problem must arise. Indeed, the second image is after the first in the list of elements, and yet it is this which is displayed in front of it. Well, yes, as all rules have their exceptions, here too, we have exceptions. The basic order of the elements at the same level is from top to bottom in the list, but the order of the elements linked to each other is from most to the right to the most to the left. So, if we have two groups of linked elements, the display order will be from the rightmost elements of the first group to the leftmost one, then, from the rightmost element of the next group to the inner list, to the leftmost one. Not always easy to manage, but it comes quickly with a little practice. Moreover, if you have opted for the option Copy, Paste, you can see that your image is in front of the first one. It is normal, since it has a displacement of -100 on its axis Z. Let's reset this value to 0. Now, in both cases, your image perfectly covers the first one. Yes, but why? Since it has no movement, it should be centered on its base support, the cube, right? Well, no, each element attached to another inherits its movements, size and rotation. So that our image inherits the rotation of the base frame, plus that of the frame of the object, in addition to its size, which is 50%, plus its animation. And finally, the position of the first image, which is at -100 on the z-axis. Well, this image will need to have its own animation, but this must be done on its right edge. So, let's move its center of rotation on its right edge, that is to say to 100 on the x-axis. We note that our image is displaced of equal value to the left. This is normal, since the images are placed according to their center of rotation and the displacement of the linked image. We therefore still have to move it half its width to the left, that is -100 on its x-axis. Here, our image is in place, and if we play the animation, we notice that it will have to give it its own animation so that it forms the cube during its rotation, and reform the strip during its last movement. To do this, our image must remain aligned when rotating the first one, and until the latter forms a right angle with it, or an angle of 90 degrees. The complete rotation of the cube being 360 degrees, we can therefore calculate that it takes a quarter of the time to make 90. Therefore, a quarter of the 8 seconds of rotation, that is, 2 seconds. Therefore, let's place a first key at the start of the rotation, when the image is still aligned, that is at 6 seconds, and check the rotation option. Then set the time 2 seconds later, that is 8 seconds, and add a second key. Also activate the rotation of this one, and let us rotate the image so that it is facing us, that is, -90 on the y-axis. Then, our image must be placed in the alignment of the first on the simulated time of the continuity of the rotation of the cube until it is perfectly centered and face on us. Therefore, its straightening will start at the end of the rotation of the previous image, that is at 14 seconds, so we place our third key at this moment, and we activate the rotation of this one. Then, we must find that fictitious time if the cube would have continued to rotate. Here is now the need for our grid. Set your time 2 seconds later, then, add the fourth key, and activate the rotation. Finally, put the rotation back axis Y on Alt. Now click on the key, and holding the click, move your key slightly to the right, or left, so that the center of the image is perfectly in the center of the screen, which is also the center of rotation of the fictitious cube, and when it is there, release the click. Your key is in place. You can play the animation to see that now, the displacement and the rotation of the first two faces are quite correct. We still have the third and fourth images to place, and you will see that it will be much easier and faster. Let's start with the third. Select the second image in the list, then copy, paste of it onto itself. The third image has been created and attached to the second. In the tab Properties, replace it with the one you want, then go back to the tab Animation. As their two centers of rotation are at their extreme right, the position of the third image, which must be at the extreme left of the second, must therefore be twice its half width, either 2 times 100% or 200% to the left. For the moment, it is at 100. So, select the first key of the third image, it is the only one which influences its displacement, and modify the value of -100 on the x-axis to -200. Now its animation. This one must perform its first rotation after that of the second image, therefore, from 1/4 to 2/4 of the time, or from the 8th to the 10th seconds. Therefore, first, move the third key from the 8th to the 10th second, then the second key from the 6th to the 8th second. For his return to alignment at the end of the rotation, it is the same process. For more precision, note the time of the last key, then move it to the right, until the third frame is perfectly centered on the screen. Finally, move the previous key to the time where the last key was, the time I asked you to take note of. Here, the third image is in place. We will proceed identically for the fourth image. Either select the third one, and make a copy, paste, and modify it. Here it is already in the right place, at -200% on the x-axis, so we can directly animate it. As for the third, we must move its animation times by more than 1/4 of the time of the rotation of the cube, that is, at the 12th second for the third key, and at the 10th second for the second. Let's proceed as for the third frame for its realignment. Note the time of the last key, then move it to the right until the frame is centered. And finally, move the penultimate key to the noted position. And now, our animation is almost over. Play it to see that everything goes according to plan. As I just told you, the animation is almost done, because if you have looked carefully you can see that the tape is rocking back and forth slightly as the cube is being rolled up. This is perfectly normal. Why? Let's look at our cube from above to understand it. The images are linked together by their edges that correspond to the corners of the cube. When we rotate our cube, we notice that they move forwards then backwards during each quarter turn of the cube. It is this displacement which generates the oscillation of our band, therefore, we must give this contrary movement to our cube to remove it. We can easily calculate this displacement. The diagonal of the cube is equal to the square root of its width squared, times 2. So the square root of 100 squared, times 2, that is, 142 plus or minus. Our cube is 50% of its size, so 50% of 142 equals 121. The displacement equals the difference between the median and the diagonal of the cube, that is, 100 minus 121 equals minus 21. Back to our animation. We have seen that this movement must be done every quarter turn. Select the first rotation key of the cube, the one at 6 seconds. Given that it is about rotation, we thus have a decelerated movement up to 45 degrees, then accelerated up to 90 degrees. So let's add a modifier to the command. Peno, let's use decelerated speed, and set it to 50%. We need to have the same position every quarter turn, so right-click on the control point, and click Duplicate the control point. This one has been added to your timeline, you just have to select it, and place it at the desired time, that is at the 8th second, and uncheck the rotate control. Let's repeat this operation in order to have the same key of the 10th and 12th second. Now let's add the first half-turn key, therefore, to the 7th second. We modify the backward displacement, that is, minus 21 on the y-axis, and we add the modifier, accelerated speed, which we also set to 50%. We still have to duplicate the key, and position it at the 9th second. And repeat the duplication for the 11th second. Here. Now the animation is complete and correct. Play it to see the final result. We have just seen how to attach images together, and give them a rotational movement between them. It is this principle that we are going to use now to curve one or more image. Only, instead of using a different image for each element, we're going to use a single image, split into multiple elements. To have a more or less correct animation, we must divide our image into at least 10 equal parts, that is, each time 1/10 of its width, or 10% of the total width of the picture. Let's put this into practice. First, as for all my animation, I create a basic frame and a control frame of the object. This done, let's choose an image, whatever its format, and, in the option Aspect Cropping, let's frame it to the desired size. Here I am going to use the 2:1 format, but nothing prevents you from choosing another format. Also check the option Base Image. This will allow you to change all parts of the image in one operation. Now a choice is needed. Either we create our image from an edge, this is useful if you want to give it a flag style animation, like this one. Or, from its center in two parts towards its edges, which is easier during a central rotation, like a tube or a sphere. We will see this option. Our image is for the moment perfectly centered on its control frame, but, given its aspect, 2:1, it covers only half of it in height. Be careful, once this animation is finished, it will cover its entire height, and twice its width. We will not need a patch of mask style to choose the visible parts of each element, because the program offers a very precise image cutting possibility, and it is that here we will use. This command is in the Properties tab, and it is the command Image Cropping. Activate it, and now you have all the cutting parameters displayed. Its parameters are in percentage of the image, and not in pixels, which allows to have the same cutout for any format or image size. Let's start with the part to the left. This is not an obligation, just a choice. So, we're going to need the 10% of the image from the center to the left. We can therefore remove the 50% on the right, and therefore enter this value in the field right. Our image is now cut in half, and you have noticed that it is centered completely on the base frame, over all its height and width, since with this cut it's become square. Okay, now we have 50% of the image, and we only need the first 10 from the right, so we're going to cut the 40% too much to starting from the left, and therefore, we enter this value in the field left. There we have our first element strip, and it is perfectly centered on our control framework. It is now necessary that its right edge corresponds to the center of the frame, and that it is the point of rotation. We can do this in one operation in the tab Animation. For information, the size after cropping and cutting of the image does not matter on the percentage of the image, which will always be equal to 100% for its half width, and to its half height obtained. So, if we move the center of rotation by 100% to the right of the image, that is, 100 on the x-axis, our image will be automatically placed starting from the center of the frame to the left. Now, at the same time, we are going to create a 180-degree curvature of the image towards us. There will be 10 elements, so each element should have a rotation of 18 degrees from its previous one. But, since the two images in the center will rotate each, their rotations will therefore add up, and therefore, they must have each half of the 18 degrees, that is, 9 degrees. Starting to the left, the parts will have to rotate anti-clockwise, and therefore, give the value -9 to the axis of rotation y. Let's move on to the second element. Let's create it by doing a copy-paste of the first on itself. For this one, as for the following ones, we must move it to the left so that its right edge corresponds to the left edge of the preceding element, so we enter the value -200 on the x-axis of displacement. It must also rotate by 18 degrees, not 9 as it is now, so enter the value -18 in the rotation field Y. It remains only to modify the used part of the image in the tag properties. We will use the next 10% to the left, so we enter the cut values of 30 for the left side, and 60 for the right side. We can now place the 3 remaining elements to the left, doing for each of them a copy-paste from the previous one, and, for the third element, we give a cut value from 20 to the left and 70 to the right. For the fourth, 10 to the left and 80 to the right. And for the last, 0 to the left and 90 to the right. We have finished the left part of our tube. We can now create the right part, which will be much faster. To do this, select the first element on the left, then make a copy of it. Select the frame of the object, then paste on it. You will notice that all the elements attached to the selected object have also been added. Now, while we are in the Properties tab, we are going to modify the part used for each element of the right part. To do this, select them in turn, and, for each of them, reverse the left and right image cropping values. But done, we still have to correctly position the elements between them. Let's go to the tab, Animation, and select the first element. We need to invert its center of rotation, so we change the value from 100 to -100 on the x-axis. And also its rotation, so we replace the value -9 to +9 on the axis of rotation Y. There remain the following 4 elements, for which we will have for each of them to modify their positions from -200 to +200 on the x-axis of displacement, their rotation from -18 to +18 on the y-axis of rotation, and their center of rotation from 100 to -100 on the x-axis. This done, our tube is entirely created, and we just have to center it on the axis of rotation of its control frame. We can calculate the necessary displacement, but it is just as fast to do it on site. Select the object frame. Then, give it a rotation of 90 degrees on the z-axis. Select the first element of the right part, then, move it on the z-axis until its right end is perfectly in the center of the screen. In this example, we have a displacement of -128. Then select the first element on the left, and give it the same displacement. Here we are. We can now rotate the tube on its center, thanks to the rotation C of the object frame. But, you will notice that as for a cube, the back faces of the image interfere with the result. We will therefore proceed as we did for a cube. Select all the images, and use the command Copy. Select the object frame, and use the command Paste. Let's go to the tab, Properties, and select the first 10 images. Then, uncheck the option, Display the back. Now select the last 10, and uncheck the option, Display the front. And there you have it, our tube is finished and can be animated flawlessly. We have half tube, we can complete it easily. First, add a square frame on our object frame, and name it Front. Then, select the first 10 images, make a copy, cut, select the frame Front, and made one, paste on it. Select the last 10 images, and cut them. Select the frame Front, and make copy. Select the frame Object, and do one paste on it. Select one of the two front frames, and rename it rear. We now have the choice. Either we keep the same image that we will invert to have continuity during the rotation. In this case, we go directly to the animation step. Or we use another image for the second half of the tube. To do this, select all the images on the back side. Uncheck the option, Main Image. Choose another image with the option, Image. Then, again check the option, Main Image. You will notice that now its value is 2. Now, in both cases, go to the menu, Animation, and select the frame, Rear. Make it make a half turn on itself to move the second image on backwards, that is to say an angle of 180 degrees on the y-axis. There you have it. If you have chosen two different images, it's over. If you have chosen the option of a single image, we will invert the back face to have an image continuity during the rotation. To do this, you just have to invert the X zoom at the frame from 100 to -100. And it's done, it's over too. You can rotate your tube to see the final result. Let us come to our sphere. The sphere is neither more nor less than a half tube that we will subdivide into slices that we will rotate on the second axis of the cube. You will see, it is very simple to achieve, but it requires a lot of elements. 400 for the base sphere. Fear not, this is more actions repetitive, and we're not going to place all 400 elements one by one. We are going to use the tube that we have just created, and we only need its front face. So select the frame, rear, and coat it. We will start with the hemisphere facing us, but we need the image to be square. Therefore, go to the tab, Properties, and select all the images. Give it the square shape with the command, Aspect Cropping, that we set to 1:1. To have a decent result, we need to subdivide our hemisphere into 20 slices. Therefore, each slice will be worth 5% of the image height. We're going to start by upper part, so we're going to use the part between 45% up and 50% down. Check that all the images are selected correctly, then enter these two values in the top and bottom fields of the image cropping control. Hella! What's going on? Our tube just got so bigger. This is normal. Don't forget that this is the useful part of the image after cropping, which will be worth the size of the frame. Now, after our cropping, the widest image width is 10%, while for the tube it was 100%. So the set has also been enlarged 10 times. Let's remedy this, and go to the tab, Animation, select the frame, Object, and reduce its size from 75 to 7.5 on its two axes X and Y. That is more reasonable. Since we changed the size of the elements, we also changed their positions, which is expressed as a percentage of the size. For proof, rotate the object frame 90 degrees on the Z-axis. And yes, the pivot center no longer corresponds to the displacement of the first elements. We will fix it. We used half of the tube image, and we enlarged it 10 times. So the ratio is 5 times greater. Select and turn the first images of each part, and multiply their displacement by this ratio. Let -128 multiplied by 5 equal -640. Enter this value for the y displacement of these two elements. Here we are, now our sphere is correctly centered on its frame. Return the object frame to its initial rotational position. We are now going to curve this first strip. we have 20 elements to make a half turn, that is, 180 degrees divided by 20, equal 9 degrees. Same as for the tube, the first two elements, top and bottom, will add their rotation, therefore, we must give each one half of its value, that is, 9 degrees divided by 2, equal 4.5 degrees. Select the front frame, and give it this rotation on its x-axis. Our first part is in place. Let's put our second strip up. Select the frame, front, then do copy, paste on itself. For the clarity of our project, select the new frame, front, and rename it to top 1. We must give it the rotation of 9 degrees and not 4.5. Enter this value in its x rotation. This strip is correctly placed, we just have to use the next part towards the top of the image between 40% from the top and 55% from the bottom. Go to the tab, Properties, and select the 10 images attached to this frame. Then, enter these values in the fields, top and bottom of the crop command. Here we have to repeat this operation for the next 8 bands. Either select the last frame created, copy and paste it onto itself, increase the name of the frame, and select the 10 images linked to it, and modify the top and bottom cropping values by 5% each time. Once this is done for all 8 bands, the last cut values being 0 and 95%, we have our first top quarter front of the sphere that is complete. Now let's create the lower front part. To do this, select the frame, front, make a copy, select the frame, object, and paste on it. Select the new front frame that has just been created, and rename it to front bottom. Then, select and turn the frames, top, and rename them as bottom, with their indexing value from 1 to 9. While we are in the Properties tab, we are going to modify the part of the images used in each band. Select each group of the 10 images in turn, and in their crop values, reverse the top and bottom values. When this is done for the 10 groups, go to the tab, Animation. Now select and turn the 10 frames, bottom, and invert the rotation value on the x-axis. For the bottom front frame, from 4.5 to -4.5, and for all other bottom frames, from 9 to -9. And done, the lower front part of our sphere is finished. Let's create the 2 back parts. For more convenience, close the 2 list of frames, front and front bottom, in the list of elements. Now select them both, and do 1 copy. Then, select the frame, object, and do a paste on it. Rename the 2 new frames as rear and rear bottom. Now, we will do as for our tube, and, in the tab, Animation, reverse the X zoom at the 2 rear frames from 100 to -100. Then, rotate them 180 degrees on their y-axis. Our sphere is completely finished. A tip: add a frame to control its movement between the frame master and the frame object, and use it to move your sphere, and the frame object to rotate it. You can also add a shadow and light mask on the displacement frame, as well as its shadow after the sphere frame, as in this example. Here we are at the end of this tutorial. You can now get started with your own creations and animations. We wish you lots of fun with the PTE AV Studio Pro program. See you soon. Katrina and Patrick.